Hello everyone and welcome to my channel. In this video we will talk about diatomic molecular spectroscopic term symbols, okay? And this video is the extension of my previous video which I have posted on atomic term symbol, okay? So if you haven't watched that video on atomic term symbol, I will suggest you guys to go and watch that video. That will be very helpful for you, and some things are correlated from that video to here, so it will be helpful for you if you watch that video and then watch this, okay? So here is the link for that video. You can go and watch it, okay? So see what diatomic molecular spectroscopic term symbol is. Like previously we have studied the term symbol when an atom is given, okay? When a single atom is given and we have electronic configuration for that, we can easily find out the term symbol in the form of 2s plus 1 lj, okay? Like their term symbols were for L value 0 we were having S, for L value 1 we were having P, for 2 we were having D, for 3 we were having F, like that, okay? But here the for diatomic molecular spectroscopic term symbol, here also the basic concept means the basic thing is same only, okay? Here also the general way of writing the spectroscopic term symbol is, see, it is delta, okay? This is capital delta over here. This is 2s plus 1, like that it was written there also. There it was 2s plus 1 L, and here it was J. But here we have 2s plus 1 lambda, and here we have G or U, okay? Either G or U. I will tell you all these things, okay? See, I have seen many videos. I tried to search many things on, like I was searching for questions on this topic, so I watched a few videos on YouTube, and I searched on internet also, but I didn't got some like solid explanation of this, okay? Like clear explanation. But I will try to explain this thing very clearly, so that in future if any question comes from this topic, you won't be able to do it wrong, okay? You will be able to do it correctly. See, this topic, like that is my molecular spectroscopic term symbol, and the previous one, that is atomic term symbol. If you prepare both of these topics, then your one question is confirmed, okay? You are going to do one question very easily, either of 4 marks or 2 marks, minimum 2 marks to you are going to get, okay? So it is very important, okay? And one more thing, that atomic term symbol topic is somewhat saturated, means lots of question has been asked from there, different types of question has been asked. So it is more probable that questions from molecular spectroscopic term symbol will be asked this time, okay? So watch this video carefully, okay? So what I was telling, that in atomic term symbols we were using 2s plus 1 lj, where 2s plus 1 was spin multiplicity, L was your orbital L was your angular momentum quantum number, and like J was having value L plus S to L minus S, okay? But here things are little different. This thing is similar only, that is 2s plus 1, that will give you multiplicity. Here lambda is same, that will give you the resultant angular momentum, okay? Resultant angular momentum quantum number, that is. And G and U, G will symbolize G-rayed and U symbolizes un-G-rayed, okay? These are the terms related to the symmetry of that orbital, okay? So G-rayed means that is symmetric, and un-G-rayed means that is antisymmetric, okay, or unsymmetric. So this is the definition, okay? This is the thing, like you have to know. And one more thing, like there it was that for L value 0 we were having S, for atomic term symbol we were having S for 0, P for 1, 1 for P, and then D for L value 2 we have D, for L value 3 we have F. Similarly here that lambda value, okay? So that L and lambda both are lambda for the atomic molecular spectroscopic term symbol. So for lambda the value 0 will give you spectroscopic state sigma, and for 1 we have pi, for 2 we have delta, and for 3 we have phi, okay? So like this we have to name. I will do questions. So see, in this video we will talk two things, we will discuss two things. First is the how to assign this atomic terms like molecular term symbol, and second thing is the question from where its application, like the which transitions will be allowed and which will be forbidden, like that questions are asked. So I will discuss that also, okay? So like this is the general thing, okay? So till here we have known that how to write it. Okay, so this is the basic thing which you all must be knowing, that electronic configuration for molecular electron like for a diatomic molecule, the electronic configuration up to 14 electrons, or element having, or a molecule having 14 electrons or less than 14 electrons have this electronic configuration, that is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px and pi 2py, both are having similar energies, then sigma 2pz, then pi star 2px, pi star 2py and sigma star 2pz. Okay, and the like for the molecules having electronic configuration of the molecules having electrons more than 14, okay, total electrons more than 14, that molecules will have electronic configuration of sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. What happens here, this sigma 2pz, this comes forward and it becomes sigma 2pz, and then it comes like these two things are like swapped. Okay, this will come forward and this will go backward here, rest is same only. Okay, so this thing you should know, then only you will be able to do this type of question. Okay, so like there are few rules I have already written, you just you can write it down, or you can pause the video and note it somewhere, or take a screenshot of this. Okay, so the rule number 1, it says that if the symbol is sigma, okay, if the spectroscopic symbol is sigma, then only plus or minus subscript are used, otherwise plus or minus subscript are not used. Okay, so this should be very clear, that plus and minus subscript will be used only if the symbol is sigma, otherwise it will be not used. Okay, then it comes that G and U refer to the orbital of the last means this will depend on the last electron filled in which orbital. Okay, that orbital will give you G-rad or un-G-rad. I will tell you how to give G-rad and un-G-rad. Okay, then like one thing which you have to keep in mind, only one thing you have to keep in mind, that is minus subscript will be written only when the electron is filled in pi orbital. Okay, when electron goes into pi orbital, then only you have to give minus subscript, otherwise everywhere you have to give plus subscript. Okay, and if two electrons are there, two unpaired electrons are there, and they are present in different orbitals, then we have to consider the like symmetry of both the orbitals. Then we have G-rad into G-rad. If both of them are G-rad, then total will give you G-rad only. If one of them is G-rad and other is un-G-rad, that will give you un-G-rad. If both of them are un-G-rad, then that will give you G-rad only. Okay, so these 4 points you have to keep in mind to do this question. Okay, now let's talk about this thing, that how to assign G-rad and un-G-rad. Okay, so like I am writing, see how it will be, like sigma 1s start with G-rad. Okay, so this will be G-rad, this will be un-G-rad. Okay, so anti-bonding orbital will be un-G-rad over here, then comes G-rad, then it comes un-G-rad. Okay, then here you have to be very careful. Okay, here the pi bonding orbitals are un-G-rad. Okay, so this will be also un-G-rad, I am writing down here un-G-rad, and it will be also un-G-rad, and sigma bonding orbital will be G-rad. See, everywhere sigma bonding orbitals are G-rad only. Okay, this thing you have to keep in mind, sigma bonding orbital should be G-rad, and for pi it will be reverse, means pi bonding orbitals are un-G-rad and anti-bondings are G-rad. So this will be G-rad, this will be G-rad, and this is, since this is sigma anti-bonding, so it will be un-G-rad. Likewise you can number over here also, this will be G-rad, un-G-rad, G-rad, un-G-rad, and then it will be G-rad, it will be un-G-rad, un-G-rad, G-rad, G-rad and un-G-rad. I think this much you have understood. Okay, so let's come up to the question and how to solve it. Okay, means we will take one example and we will solve it. Okay, so we are taking one example, that is helium plus 2 molecule. Okay, so for this molecule the electronic configuration will be sigma 1s 2 and sigma star 1s 1. Okay, like this it will be, and this will be G-rad and this will be un-G-rad. Okay, see, as you know that for s orbital the last electron lies in s orbital, so you have to do everything with that only. So for s orbital the L value is 0, so you have one electron over here, the unpaired electron, the last electron lies in this, so you have to make everything according to this only. So the value of L or the value of lambda, you can take any of them. So the value of L or lambda will be 0. Okay, then it comes that we have one unpaired electron, so value of S will be 1 by 2, because for one electron, unpaired electron, the value of S is half. Okay, now we will try to assign the term symbol. See, for L or lambda 0, we have from previous table we know that we will get sigma as the term. Okay, so the spectroscopic term will be sigma. Now here we have to write 2s plus 1, and here we have to write either G or U. So the last electron, that means the last electron was there in like ungyred orbital, so here we have to write U. Okay, now let's simplify first. So if you put the value of 1 by 2 over here, so it will become, I am solving it here, 2 into 1 by 2 plus 1, this will give you how much? 2. Okay, so here this whole value will be come to 2, then sigma. Okay, and we have U. And rule number 1 says that plus and minus subscript will be written if the spectroscopic term is sigma. So here we have a spectroscopic term sigma, so we have to write plus and minus, plus or minus subscript. Okay, it is written over here. So what to write, plus or minus? So I have told you in the rule that minus sign will be written only when the electron will be in pi orbital. So here electron is in sigma orbital, sigma anti-bonding orbital, so it is not in pi orbital, so that means we have to write here plus. So the microscopic the molecular spectroscopic term symbol for helium 2 He2 plus molecule, that will be 2 sigma ungyred and this plus. Okay, so like this you have to assign. I will take one more example which was asked in the question. Okay, let's take another example, that is O2 molecule. Okay, so here see, one oxygen will have 8 valence electrons. So for O2 molecule we have 16 electrons. Okay, we have to fill them in the electronic configuration according to those who are having more than 14 electrons. Okay, so that was sigma 1s, sigma star 1s, then sigma 2s, sigma star 2s, then it was sigma 1s, sigma 2 star 1s, sigma 2s, sigma star 2s, sigma 2pz, then it was pi 2px is equals to pi 2py. Okay, and then it was pi star 2px is equals to pi star 2py, and then it was sigma star 2pz. Okay, so let's fill them. So here 2 electrons, then 2, then 2, then 2 and 2 over here. So we are having 2 plus 2 plus 2 plus 2, that is 10. Okay, then 11, 12, then 13 and 14, like that we have to fill. Okay, first one here, then next one. Okay, I know that thing, you should be knowing these things. Okay, so up till here 14 electrons, then 15th and 16th. Okay, so like this is the electronic configuration. So the valence shell means the last electrons are filled here, so we have to assign the term symbol according to this only. So the first thing is the value of spin multiplicity, that is S. So we have 2 unpaired electrons, means 2 into 1 by 2, that will give you 1. Okay, so the value of S is 1. Okay, now we have the value of L. See, for calculating the value of L, and when the electrons are in these orbitals, means px and py orbital, you have to be very careful. Means for p orbital you have to write like this. We have 3 orbitals, you have to be very careful over here. This is px, this is py, and pz is the middle one. Okay, this you have to be very careful. So for this px we have value plus 1, for pz we have 0, and for py we have minus 1. This you know from the from there also, like from atomic term symbol also we used to do like this only. But here you have to be careful about px, py and pz, how to assign them. Px here, py here, and then pz here. So the 2 electrons are in px and py. See why it is so, because it is equal sign is written over here, means the energy of both of them is equal. Okay, means both of them should be equal. So one cannot be one, means it cannot be like this px and py, because one px will get value +1 and py will get value 0. Okay, so we have to write it like this: px and py both are having value 1 only. This plus and minus sign, like it, some books you will find plus here and minus here, that doesn't matter. Okay, so but I will suggest you that this use this way only. This is the standard way. Okay, so +1 here and then -1 here. Okay, so the overall L value we will get as +1 and then -1, that is 0. Okay, so the L value will be 0 over here. And as I have told you that the pi electrons, the pi orbitals, when they are bonding they are ungerade, but when they are anti-bonding they are gerade. Okay, so that I have told you. So here we have to see that thing, like, okay, so let's do that. Like according to the first rule, it says that if the value of L is 0, then we have sigma as the spectroscopic term. Okay, then spin multiplicity is 2s plus 1, that means 2 into 1 plus 1, that will give you 2 into 1, that will give you 1, means 2 plus 1, that will give you 3. So spin multiplicity is 3, so I am writing 3 over here. And then you have to assign G or U over here. So for that we will use rule number 4, that means if electrons are present in two different orbitals, then we have to write like this: G and G. So G cross G means G into G, that will give you G rate, that I have written in rule number 4. So I am following that only, so it will become G rate over here. Okay, and here we have to write either plus or minus, and that is only written if the spectroscopic term is sigma. Okay, so plus and minus, this depends, like if your electrons are in, I have told you, if electron is in pi orbital, then only you have to write minus, otherwise you have to write plus. So here it doesn't matter electron is in pi bonding or anti-bonding. If the electron is in pi orbital, you have to write minus, so here you have to write minus here. Okay, so like this it will be the spectroscopic term for O2 molecule. Okay, so now we will try to solve few questions which were asked in CSIR exam. Okay, so we have a question that was asked in CSIR December 2016 exam, and see, this question came for 4 marks. Okay, so that means that from this topic you can easily score 4 marks, up to 4 marks. Okay, and I must remind you that few more questions were asked from from determining the atomic turn symbol and the number of microstates. Okay, so if you prepare all these 3 topics, okay, that is atomic term symbol, molecular term symbol, and number of microstates. Okay, so like 6 marks is in your hand. Okay, so all 3 videos I have already posted. These are from physical chemistry topics. So if you are like, if you are preparing for organic and inorganic as your combination, and like if you watch these 3 videos, I am sure that you will get these 6 marks as bonus in your physical chemistry. Okay, so let's solve this question. See, the question seems to be like that the highest molecular orbital for an excited electronic configuration of oxygen molecule are 1 pi g 1 and 3 sigma u 1. This G denotes the G-rayed and U denotes ungerayed. Okay, and there are 2 unpaired electrons, one lies in the pi orbital and one lies in the sigma orbital. And it is written that a possible molecular term symbol for the oxygen with this electronic configuration is. See, the question is very easy. Okay, I will tell you how. Okay, see, so it has asked that the possible molecular term symbol. Okay, it has not asked that what will be the molecular term symbol, it has asked the possibility. So that possibility you can only get like you will get by doing one step only, you don't have to do all the steps. Okay, see, this question is quite similar to a question which was asked for finding the atomic term symbol, which was asked in, I think, in June 2016 exam. Okay, which I have solved already in the previous video where I have talked about the atomic term symbol. Okay, the link I have already given you. So in that video, like I have solved that question. There also the two electrons were, one was in s orbital and one was in p orbital, and it was asked to find out the atomic term symbol. Okay, here they have given two electrons, one in pi orbital, one in sigma orbital, and they have asked you to find out the molecular term symbol. Okay, so this is very easy. Okay, I will tell you how. See, for like one electron is there in pi orbital and one electron is there in, I am just writing that one sigma 1. Okay, I am not writing g and u, and 3 1 pi 1 and 3 sigma 1. Okay, so like two electrons are there, one lies in sigma or pi orbital and one lies in sigma orbital. So to find out the value of L, that is sigma L, means the total, I am not writing sigma so that you won't get confused. The L values means the total angular momentum. Okay, angular momentum quantum number value, that I have already also denoted it with lambda. Okay, to find out this, we write down the value of, like for sigma orbital, like it is not written s or p over here, so sigma is basically s orbital only. Okay, or it may be p orbital also, but for sigma the value of lambda or L is 0, and for pi the value is 1. Okay, like we have already discussed. See how, like we have sigma s, for sigma s also we get value 0 only for L value. Okay, and we one more thing we have, that is sigma pz. I have told in previous example that for pz, p orbital have three like px, pz and py. For pz we have value 0, and px have value of +1 and py have value of -1. Okay, so for pz we have value 0. So all the sigma orbitals, like these are the only two sigma orbitals which are in the electronic configuration, so we have L value 0 only. Okay, and for pi orbitals we have pi px and pi py. Okay, so for those two we have L value 1. Okay, so we will write it as like this. Okay, so we have to write it like this. For pi we have value 1, and for sigma we have value 0. So overall we get as 1. Okay, and I have already told you that if L value is 0, 1, 2, for L value 0 we denote it as sigma, for 1 we denote it as pi, for 2 we denote it as delta. Okay, so here the value is 1, so we will denote it as sigma, pi. So the term come out to be, the spectroscopic term come out to be pi. And you don't have to do further in the, for all four examples, all four options, there is only one option in which we have pi as term, so the answer will be first. Okay, before going further, like I have told you that one more part, like one more type of question are asked from this topic, that are allowed and forbidden transitions. Okay, like this type of question I remember it is asked in GATE exam. Okay, and it can be asked in CSIR also, so we will be well prepared for that also. So see, for allowed and forbidden transition there are certain very basic rules. Okay, the first rule, that is for allowed transition only the rules are there, if you remember them. If the rule doesn't follow this thing, then if the question doesn't follow this rule, then that will be forbidden transition. Forbidden and allowed means the transition will take place, or forbidden means it will not take place. Okay, so it's like that. So the first allowed transition will be if the delta lambda is 0 or ±1, then only it will be allowed, otherwise it will be not allowed. It means that the transition is taking place from a spectroscopic term to a different spectroscopic term, and if both of them are same, means the change in them is 0, then that is allowed. So like this it is allowed. And if there is change of 1, like for L is equals to 0 we have sigma, and for L is equals to 1 we have pi, so if from 0 to 1 we are moving, then also it is allowed. Or for delta, the value of L is 2, and for pi the value of L is 1. So if we are moving from delta to pi, then there is change of 2 minus 1, that is change of 1 only, so then also it is allowed. Okay, but if you want to move from sigma to delta, means say for sigma L value is 0 and delta value is 2, so if you are moving from 0 to 2, that will give the delta lambda, means the change in the lambda value will become 2, so that will be forbidden transition. Okay, so the transition will only take place if the delta lambda, means the change in lambda is 0 or plus minus 1. Okay, other thing is that the change in spin should be 0, means the spin multiplicity, here we should write spin multiplicity, means the 2s plus 1 value. Okay, so this is not delta s, that is delta 2s plus 1 value. Okay, so this should be equal to 0, this term should be equal to 0, means the change in spin multiplicity should be 0. Yeah, means the spin multiplicity should be same. So like this, see, here it is also 1, here it is also 1. This is allowed because the spin multiplicity is also same, and the delta value means the lambda value here is 0 and here is 1, so that is also from first rule it is allowed. So both rule will combine tell you that this transition is allowed transition. Okay, third thing is the transition will take place from plus to plus, means the subscript is plus over here, so there also you have to be plus subscript. From minus to minus, means the subscript, if minus is here, here should also be minus, and if grade is here, so it will means the transition will take place when grade is converted into ungrade, means if here is grade, you have to be here ungrade. Okay, so like this, here is grade, here is ungrade. I will try to find a question to tell you in more detail this thing. Okay, this question came for 2 marks in June 2016 exam, and the question says that the first accepted state of hydrogen molecule is. So for this question I am leaving it like this only, like I am leaving it up to you people, so that you people can solve it. Okay, if you feel any problem in solving this question, you ask me, I will solve it in comment section. Okay, so this question is for you guys, solve this. I hope you people will be able to solve this. Okay, so I'm just telling you the electronic configuration so that it becomes little easier for you. So for a hydrogen molecule, it is like H2, and the electronic configuration will be sigma 1s2. Okay, but for excited hydrogen molecule, that will be sigma 1s1 and sigma star 1s1. Okay, so now I hope that you people will be able to get the answer. Okay, so this question was from June 2016, so I'm leaving for you. Next question, which was from the from the symmetry allowed, question says that the symmetry allowed atomic transition among the following is asked in December 2015 for 4 marks. Okay, the question was not from molecular transition, but it was from the atomic transition. Okay, atomic term symbol, but it follows the same rule like we studied for the molecular one. Okay, that means that the delta s should be 0, means the change in the delta 2s plus 1 should be 0, means the change in spin multiplicity should be 0, and the change in L value should be either 0 or plus minus 1. Okay, so these two rules we have to follow here. G and plus minus, those rule will not be applicable, only these two will be applicable. So for this since it first says that the spin multiplicity should be same, so here the spin multiplicity is different, so this cannot be the correct answer. Here also the spin multiplicity is different, so this also cannot be the correct answer. Among here the spin multiplicity is same and this is also same, so among these two only we have the correct answer. Okay, so let's check the other thing, means that the delta L should be either 0 or plus minus 1, means either the difference should be 0 or should be equal to 1. So here the difference means the L value for f orbital is 3 and the L value for d orbital is 2. Okay, so the change means delta L is 1 here. Okay, plus 1, and here for f orbital it is 3 and for p orbital it is 1, means the delta L value, change in L value is 2 here. So this cannot be correct answer, this one is the correct option. Okay, so like this I tried to solve as 3-4 questions which I found from previous CSIR exam. If you find any other questions which you are not able to solve after watching this video also, then you can comment in the you can give the question in the comment section. And I hope that you people like the video, and please hit the like button and subscribe the channel. Okay, thank you for watching.